All right, so when you are ready, I don't know why that is covering the answer. Yeah, that's not very helpful. You should have x to the power of 4 minus 10x cubed plus 41x squared minus 50x is what you should get. When you bring 0 back over with x, isn't it still just 0? I mean, still just x. X plus 0 is just x. When you bring 2 back with its x, it becomes x minus 2. Yeah? Here, we're going to have x, move it over, minus 4, and then plus 3i. And my other one becomes x, move the 4 over by subtracting, move the 3i over by subtracting as well. All right, I'm going to do these first two together. X times x minus 2 is going to give me x squared minus 2x. These two lovelies, I'm going to do a little chart over here. X minus 4 minus 3i, and then x minus 4 plus 3i. All right. X times negative 4 times negative 3i. My next row, that becomes negative 4x, positive 16, positive 12i. And then my final row becomes 3ix, that becomes negative 12i, and negative 9i squared. Okay, negative 9i squared, we know we can change that to a plus 9. So we start combining like terms if we can. We also cancel things out if we can. So x squared, I believe, is the only x squared. Yep, so it stays. All right, negative 4x gives me negative 8x. Okay, 3ix, negative 3ix, they cancel. Negative 12i, positive 12i, they cancel. Now I have 16 plus 9, which is 25. So remember, because they're conjugates, there should not be an I in our answer. That's how I knew something was wrong when we were going over the homework. There should not have been an I in the answer, because if we use conjugates, that's the whole point. It gets rid of square roots and it gets rid of i's. They shouldn't be there anymore. Okay? From here, you're going to multiply those guys out. So you would distribute x squared times x squared is going to give me x to the power of 4. X squared times negative 8x gives us negative 8x cubed. X squared times 25 is positive 25x. Then we do it again with negative 2x. So that gives me negative 2x to the power of 3. Positive 16x squared. And then negative 50x. Combine like terms. X to the 4 stays. Negative 8 minus 2, that's where our negative 10 comes from, for my x to the power of 3. I only have, I'm missing something. Oh, that should be a squared. There we go. 25 plus 16, that's where our 41 comes from. And then we have minus 50. Okay, so that's working backward. That's if we give you the roots and we're asking you for the polynomial it came from. Does it make sense that my answer is a degree of 4? Yeah, because technically we had how many solutions? We had 4 solutions. Bonus question, how many of those were real solutions? And how many were imaginary? 2. Good. So, another bonus question, how many times does this polynomial cross the x-axis? Twice. Nope, it only crosses at the real ones, the 0 and the 2. Those are the only solutions you'll see on the graph, because the other two are imaginary. They're not going to cross the x-axis. They're in that other dimension. Remember that video? Yes. Hurry. Questions on the warm-up before we get started today? We're going to do more practice with using our calculators to find a solution, synthetic division, that whole shebang. Factoring. All right. All right, so we're going to continue to find all our solutions today. The steps we're going to take, which are the same steps we did yesterday. Step 1 is list all possible rational roots. That's your P's over Q's. Okay, so the positive and negative factors of P over the positive and negative factors of Q. Step 2, we're going to find one that works. So if we don't have a calculator, we start plugging things into our equation to see which one makes the equation equal 0. Suggested using the whole numbers first. But if we have a calculator, we're going to graph it, and we're going to actually see where it crosses the x-axis. And then use one of those points to test in step 3 of synthetic division. We know it works if what? If what happens in my synthetic division? We don't have a remainder. Good. And then what we have left, we factor to find my other roots. Okay? Because we have an x cubed, so if we find one of my solutions, I have 2 left to go, right? So I'll have an x squared function to work with. Okay, so with this guy, let's make our list. P's over Q's. So which one's the P? The -3 on the end. And what's my Q? Good, it's a 1 right here. So we're going to have positive and -1 divided by positive, -1, and 3. So this list is going to be 1 divided by 1 and 1 divided by 3. That's a nice little short list, right? So how many possible places can it cross the x-axis? Oh, kids, I totally messed that up. And you didn't stop me. Look, I even labeled P, I labeled Q, but then I didn't do it the right way. P's are 3. Q is 1. There we go. 1 divided by 1 is 1. 3 divided by 1 is 3. Lord. How many possible places can we cross the x-axis? 4 possible places. 1, -1, 3, and -3. Okay. So we're going to use our graphing calculators, and we're going to see which one of those work. Okay. There's 4 possible solutions. How many are we actually going to have? We're going to have 3 solutions, right? So graphing calculators, get those up. All right. So a refresher, you're going to push y equals. If something is there, you're going to push clear to get rid of it. We are going to do x raised up to the power of 3 minus, don't push the negative button, make sure you push the minus button, 3x squared plus x, and then minus 3, and go to our graph. Ooh. So where is it crossing over? Looks like at positive 3, right? We are crossing over at an x of 3, right? But we thought it was supposed to have 3 different solutions. We're going to have 3 solutions, but guess what? They're going to be imaginary. My other 2 are going to be imaginary. So this is going to have 1 real and 2 imaginary solutions. Okay? So let's test our 3. I'm going to go back. So we're going to test 3 in my synthetic division. Coefficients, make sure we have everything represented for our highest exponent all the way down to our constant. So we have x cubed, x squared, x to the power of 1, and none. They're all there. 1, -3, 1, -3. Drop down the first number, set it up for its free throws. Bounce the basketball. 3 times 1 is positive 3. Now 3 times 0 is 0. 3 times 1 is positive 3, which gives us 0. So that just proved that it is a root. Okay? Now I have to factor to find the other roots. What quadratic are we going to factor? Yeah, x squared plus 1. Good. Because it's x squared, x, right? And then 1. So x squared plus 1. How can we solve this? Yeah, minus 1. X squared equals negative 1. Then what? Square root. What's the square root of negative 1? And negative. Positive and negative I. So my 3 roots here are 3, positive I and negative I. So there's my 3 different ones. Yes? What? Because that was my answer from my synthetic division. Yeah. Because we started off with an x cubed, but we're taking an x out, so that's why it drops down to an x squared. How we feeling? We okay? Yes? We're going to move on to this example. We have x cubed plus 4x squared plus x minus 6 equals 0. Okay? I want you to make your list of p's and q's, and I want you to find one that works. All right, I'm going to pause and let you do that much. All right, when you looked at your graph, didn't you have 3 options? Whoop. -2, -3, 1. I believe it looks something like this, right? Did it matter which one you picked to test? Do you think it matters? No, it does not matter which one you picked. So if you picked 1, but your partner next to you picked the number -3, you're both going to end up with the same 3 solutions in the end. Okay? It doesn't matter which one you test, but you got to test one of them. What's nice about this is we know what 3 we should get. So once I test 1, I'm going to test the number 1 personally. I'm going to put 1 in the corner. My coefficients are 1, 4, 1, and -6. Drop down this guy. Down to the basketball. 1 times 1 is +1. Add these together to get 5. 1 times 5 is +5. Add these together to get 6. 1 times 6 is +6. Add those together to get my 0. So there we go, right there. We proved that 1 is a root. And now we're going to take x squared plus 5x plus 6 and factor it. This one we can use basic factoring. So it multiplies to give me 6, but adds to give me 5, is a +2 and a +3. So we make each of those equal to 0 and solve for x. We get x equals -2 and x equals -3 out of it. So we have 1, 2, 3 solutions. Yeah, we good? That was pretty basic. I'm going to level up a little bit. Yay, I know you're excited. Yeah, it does. Yep. X to the 5th plus 3x cubed minus 4x equals 0. Okay, good times. Okay, if we make my list of p's over q's for this one, something kind of happens. Because what's my p technically? 0. So if I do positive and -0 over positive and -1, that tells me that my only solution is 0. Does that even make sense? Let's see. Let's see if that even makes sense. I don't know. We're going to see. Okay. Graph it. Graph it and see what happens. We should have 5 answers. We need to have 5 answers. But my list is only 1 number. That's odd. Where's my calculator? There it is. All right, so we have x raised to the power of 5 plus 3x raised to 3, and then minus 4x. Graph it. Oh, look at, oh, I did something wrong because that's not right. Oh, yeah, it is. We're okay. Scared me. Okay. My P's and Q's aren't going to help me a whole lot here, are they? But one of them, the one that was on my list, would you say that that is definitely a solution looking at my graph, going through the origin? Yeah? So let's use that one to test. Okay. So we're going to test that guy. Also, bonus question, your graph showed 3 places where it's crossing, right? But how many are we supposed to have? We're supposed to have 5. So what do you think the other 2 are going to be? They're probably going to be imaginary. Yep. All right, well, it's my coefficients. This is wrong. Why is that wrong? We need my placeholders. Yes, x to the 5th has a coefficient of 1. X to the 4th isn't there. X cubed, that has a coefficient of 3. X squared, not there. X has a coefficient of -4. And what's my constant at the very end? Technically, it's a 0. All right. Drop down my number 1. 0 times 1 is 0. Add those together, I get 0. 0 times 0 is 0. 3 plus 0 is 3. But 0 times 3 is 0. Add them. Multiply. All right, -4 plus 0, that's -4 times 0. Okay, lots of zeros happening. But the 0 on the end proves that the origin is a root, so then we know that's part of my list. So the function we're going to have to now factor is going to be x to the power of 4 plus 3 to the power of 2, good, minus 4, like that. Good times. Okay, this is one of our special factoring methods the other day. There's 3 pieces. The first and last piece are perfect squares. Well, that's not going to work for me, is it? Hold on. Oh, I'm making this way too hard. We can just do basic factoring. Hold on. Yeah, I'm making it too hard. Yeah, x squared plus 4, and then x squared minus 1. Thank you. I got excited. So multiply is to give me -4, adds to give me 3. That's my 4 by -1. To split apart the x to the 4th is where I get x squared from. All right, now I got to take both of these and equal to 0 to solve. So if I have x squared plus 4 equals 0, subtract my 4, square root, and we're going to get what? We're going to get what? We're going to get what? Plus or minus 2i. Don't forget the plus or minus. I's have conjugates. There's 2 of them. And then my other one, x squared minus 1 equals 0. I'm going to add my 1 over. Square root this. So what do I get here? Plus or minus 1. So do I have my 5 answers now? Yeah, it's going to be 0, 1, -1. Didn't it kind of look like 1 and -1 were happening on the graph? Okay. It went through like that. And these looked a whole lot like -1, +1. And they were. And then my other 2 solutions are 2i and -2i. So there's all 5 of my solutions. Yeah, you can. I think that's how I have it typed on here. Yes. Okay. Questions? I'm going to level up again. Yeah. then if you have a remainder, then what you tested is not a solution. And you got to go back and find one that is. Yep. Okay. If you have a remainder, it's not going to be a solution. So if you end up with the remainder, that means that you messed up. There should not be a remainder. All right, level up time. Woohoo! We got good news, we got bad news. Good news, we're not missing anything. I don't need any 0 placeholders. Okay? Bad news, well, I don't think it's bad news. I'll wait for the bad news. I won't give it to you just yet. You might think it's bad news. I don't think it's bad news. First thing, always make our list. Okay? My P's will be the factors of 18. So what multiplies to give me 18? 3, 6, 9, and 18. All right, and then my factors of Q. Well, that's nice. So we have positive and negative 1, positive and negative 2, 3, 6, 9, and 18. All right, so how many possible places can we cross over? From my list, hold on. How many possible solutions can we pick from because of the list? We have 12 options. Good. How many are we going to have? 4. There we go. I needed to ask the question better. Okay. What's nice is there's no fractions, right? They're nice whole numbers, so my graphs are hopefully easy to read. Okay. So graph this. It's not easy to read. Let's look. Here we go. X raised to the power 4. And if it's not easy to read, then I will love to show you how to make it easy to read. Raised to 3 minus 7x squared minus 9x. Oh, man. Well, there we go. Minus 18. Okay, graph. Let's see what we mean. What do you mean it's not easy to read? That looks like a negative 3 and a positive 3. I mean, I can't see the whole picture, but I can see 2 possible places it's crossing over. Okay? Oh, yeah, you done messed up. All right, so do you want to test 3 or negative 3? 3? Sounds good. Okay, let's test 3. Okay. So all my coefficients are there. I don't need any placeholders. Drop down this guy. 3 times 1 is positive 3. Add them. Multiply. We're going to add again. Multiply. I know I'm adding because I keep getting positive numbers. Negative 9 plus 15, what is that, 6? And then, there we go. All right, so we have proved that 3 is a remainder. Okay. So now we have, this is x, what, to the power of 3 plus 4x squared plus 5x plus 6. Ooh. Usually when we factor, it's powers of 2, not powers of 3. So here's this is what you might think is bad news, but we can do synthetic division again. We had another test number, didn't we? We had negative 3. So let's use it using the answer we just got. So let's do negative 3 from here. Minus 3, that gives me 1. Minus 3, that gives me 2. Look at that. So I just proved that 3 and negative 3 both work. So I can use the answer to my first synthetic division and test another point to prove it again, to continue to move down. Because now I've dropped down another degree. I have 1x squared plus 1x plus 2. And I can factor that, right? X squared plus x plus 2. Use what? You did. It's just there's no way to factor that. Okay? Hey, hold on. What? I don't know what's happened right now. You're going to wait a second. The bell did not ring. Okay? Because you're going to do this for your homework tonight. Does anything multiply to give you 2 and add to give you 1? No. Can you do slip and slide? What are you going to have to do here? Quadratic formula for this guy. Yep. You should get positive negative I square root 7 over 2. Those end up being your answers for this problem. All right, do your homework.